okay, so think about this for a second, right? You're in a world that's like totally powered by networks, right?
Yeah.
And keeping those networks not just, up and running, but like humming, efficiently. Like, that's the game now, right?
That's the challenge, isn't it?
Yeah. So if you've ever thought, like, man, there's got to be a smarter way to handle all this complexity, you were the right place, my friend.
Absolutely.
So today we're doing a deep dive into network automation, and we've got some pretty interesting material to work with.
Yeah, for sure.
Believe it or not, it's actually based on practice questions for the Juniper JN0-224 certification exam.
Oh, wow.
But hold on. Okay, this isn't about like, test prep or cramming or anything like that.
Great.
Think of it more as like a focused look at the fundamental concepts that really make network automation work,
Yeah, I like that approach. Using these questions as a springboard to really explore the concepts.
Yeah, exactly. And especially the reasoning behind the answers.
Yeah.
That gives us like a really practical way to kind of examine the core principles of play.
Yeah. It's like distilling it down to the essential ingredients.
Exactly. So your mission today, should you choose to accept it,
I think I will.
is to extract like the crucial knowledge nuggets about network automation, right?
Sounds good.
Because how about the language these systems use, like data formats, the tools that make it happen, automation frameworks, the power of scripting, how different systems talk to each other, APIs and the rules that they follow, like configuration management protocols.
Right.
So we're going to unpack all these ideas so you come away with like a real solid understanding of what makes network automation tick.
Let's do it.
All right, so to kick things off, how do these automation systems even structure their conversations, their data?
Well, at the most basic level, right, we're talking about data serialization formats. And this first question that we're looking at brings up two big ones, JSON and YAML. And the correct answer here points out that YAML gives you this flexibility of both inline and block style formatting.
Okay, so let's break that down. What does that flexibility actually mean for somebody who's trying to automate a network?
So it really comes down to readability and adaptability, right?
Yeah.
Which becomes super important when you're writing and maintaining automation scripts, configuration files, all that good stuff.
Sure.
YAML's block format, with its reliance on indentation, it makes it very human-friendly, especially when you're dealing with these complex data relationships.
Yeah.
You can also use a more compact inline style when that makes sense, but JSON, while it is structured, it's a bit more rigid in its syntax, right?
Yeah.
Curly braces for objects, square brackets for arrays.
Right.
And while indenting JSON is, good practice, the machine doesn't really care.
Yeah, I've noticed that.
The explanation also mentions something about comments, which is interesting.
Yeah, why is that even relevant, comments in code?
Well, this gets to the human side of automation, right? The explanation notes that JSON doesn't support comments. I don't think our source material mentions if YAML does in this context, but it's widely known that YAML does allow you to add comments using the hash symbol.
Right.
And this can be a real lifesaver when you're documenting your automation setups, right? Making them easier for others or even your future self to understand.
Future self. Yeah, that's an important one.
Huge.
So YAML sounds a bit more like you're writing notes to yourself in the code, which can be pretty helpful down the road.
Yeah, and that can be a real advantage for initial setup and configuration.
Okay.
Now, on the flip side, you might find JSON's parsing speed and its widespread support in web technologies to be advantageous when you're dealing with high-volume data exchange between different systems, especially in a large-scale automation pipeline.
Oh, interesting. Okay, so different tools for different jobs.
Exactly.
All right, well, let's shift gears a bit. Question 2 looks at Juniper's specific automation tools. So what is the core purpose of the Junos automation framework?
Well, this is really cool because Juniper has these tools that are specifically designed to manage their devices programmatically. And the primary function of the Junos automation framework, as this question highlights, is to enable you to run scripts to automate network configurations and monitoring.
So it's like the internal engine that lets you automate tasks directly on Juniper equipment.
Exactly. Think of it as the infrastructure within the Juniper device that allows you to execute automation scripts.
Okay.
Typically written in languages like SLAX and Python and run them right there on the box.
So this framework is really what allows admins to move beyond manually entering commands, in the CLI for every single change or monitoring task.
Absolutely. It's about reducing that manual effort, increasing efficiency, and ensuring consistency across your configurations.
So instead of like logging into a dozen devices and typing the same commands over and over again,
Yeah.
you write a script once, And this framework takes care of running it, across your entire network.
Exactly. And you're far less likely to have those typos or those discrepancies when you're using automated scripts managed by the framework.
That sounds like a huge efficiency boost.
Absolutely.
All right, question 3. 3 delves into a little bit of programming with Python sets.
Okay.
So why are Python sets something we should even be thinking about, when we're talking about network automation?
Well, this raises a really important point about how you handle and process data in your automation workflows.
Okay.
Python, as we mentioned, is a popular language for network automation, and sets are a really useful data structure for certain types of tasks.
Okay.
The question highlights 2 key properties of Python sets. 1, they're unordered collections of unique elements, and 2, they support mathematical operations like union and intersection.
Okay, so unordered and unique, those are the crucial bits to remember, right?
Exactly. And that unique aspect is incredibly valuable.
Yeah, okay.
Imagine you have a list of device IPs or MH addresses, and you want to make sure that you only have distinct entries.
Right.
Putting that list into a Python set will automatically get rid of any duplicates for you.
Oh, that's cool.
Now, the unordered part does mean that you can't count on those elements being in a specific sequence, and you can't access them by index like you would in a list.
Okay.
But the mathematical operations, union and intersection.
Yeah, how might those be relevant to somebody who's managing a network?
Well, think about it like this. Imagine you're comparing VLAN configurations across different devices.
Okay.
You might have a set of VLANs on one switch and another set on a different switch.
Right.
Using set operations like union, you can instantly see all the VLANs that are present across both devices.
Oh, okay.
Intersection would tell you exactly which VLANs are configured on both.
Oh, that's really useful.
Yeah, so these kinds of operations can be very powerful for analyzing that network data and ensuring that configurations are consistent across your entire infrastructure.
That makes a lot of sense. Okay, moving on to question 4. We're talking about how devices share data for automation. So what is the standard language when you're using the Junos REST API?
Well, this is where we get into the specifics of machine-to-machine communication. And the question correctly points out that the default format for data returned by the Junos REST API is XML.
XML? I often hear about JSON being the go-to these days, for APIs.
Right.
So why would Junos default to XML?
That's a good question. And while JSON is definitely gaining in popularity, for its simplicity, XML has a longer history in network management,
Yeah.
and it offers a really structured way to represent complex hierarchical data, which is often what we see with network configurations and operational details.
Makes sense.
XML also allows for schemas and validation, which can be really helpful for ensuring data integrity. So Junos does support JSON in a lot of situations, but XML has traditionally been the default for its robust capabilities in representing that detailed network state.
Okay, so it's good to know that XML still plays an important role, in that context.
Absolutely.
All right, question 5 takes us back to YAML and digs a bit deeper into its syntax.
Okay.
So what are the most important syntax rules to keep in mind when you're working with YAML?
This question really highlights why YAML is often preferred for those human-readable configuration files, and 2 key aspects of its syntax, as pointed out here, are 1, indentation is used to define nesting, and 2, lists are represented using dashes.
Indentation for nesting, that seems like a big win for making complex configurations, easier to visually understand.
Absolutely. Unlike JSON, where you're relying on curly braces and brackets to see the structure, YAML uses whitespace.
Right.
And this clean visual structure makes it much easier for you to parse and understand those configurations at a glance.
Yeah, I can see how that would be a lot easier.
And the use of simple dashes to denote items in a list is also very straightforward and intuitive.
Yeah, for sure. And the question mentions that keys and values always need quotes, and that YAML is always single line. Are those correct?
No, those are actually both incorrect. YAML is actually quite flexible.
Okay.
You don't always need to put keys and values in quotes, unlike JSON, where strings generally do need those quotes.
Okay.
You typically only use quotes in YAML if there might be some ambiguity or if you're using special characters.
Right.
And YAML definitely supports multi-line data using what's called block formatting, which is essential when you need to represent larger chunks of text or more complex data structures.
So readability and a good degree of flexibility, those seem like the major advantages of YAML.
Absolutely.
All right, well, let's talk about how these automated systems communicate securely.
Yeah.
Question 6 brings up netcon and how it transports its data. So what are the secure ways to use netcon?
Okay, so to connect this to the bigger picture of managing network devices securely, right? NetConf, or Network Configuration Protocol. Gives you a standardized way to configure those devices through machine-to-machine communication.
Okay.
And just like any management protocol, it needs a secure way to transport its messages. And this question correctly identifies SSH or Secure Shell and HTTPS or Hypertext Transfer Protocol secure as the two protocols that can be used with Netcon.
Okay, so SSH makes sense for secure command line access. Why would you use HTTPS with Netcon?
HTTPS becomes particularly relevant when you're integrating Netcom with RESTCOM.
Okay.
RESTCOM provides a more web-friendly, RESTful interface for network configuration.
Right.
HTTPS provides the encryption and authentication over standard web protocols, making it a good fit for those web-based management and automation workflows that might be using RESTCON as the intermediary.
And Telnet, which was one of the options, is definitely not a secure way to go, right?
Absolutely not. Telnet transmits all of its data in plain text, including usernames and passwords,
Oh, wow.
making it incredibly vulnerable to eavesdropping.
Yeah, not good.
In today's world, especially with automation where you might be making widespread changes, security is paramount.
Right.
So Telnet is just not a suitable transport protocol for Netcon.
Okay, that makes perfect sense.
Okay.
Let's talk about a really popular automation tool, Ansible.
Okay.
Question 7 asks about its main advantage. So what makes Ansible stand out, in the world of network automation?
Well, one of the most interesting things about Ansible is its fundamental approach to automation, and the question correctly highlights its push-based configuration model and the fact that it doesn't require any agents on the network devices you're managing as a significant advantage.
Agentless, that sounds like it could really simplify things when you're, setting things up and managing them.
Absolutely. With a lot of other automation tools, you have to install software agents on every single device that you want to manage.
Yeah.
Ansible, on the other hand, connects to those devices remotely, typically using SSH for network devices.
Okay.
And it pushes the necessary configurations and commands. This agentless architecture really simplifies deployment management, and it reduces the resource overhead on the devices themselves.
And the push-based model, what does that mean for how you interact with your network?
So that means that the central control node where Ansible is running initiates the connection to your target devices and pushes those configurations or executes those tasks.
Yep.
This is different from a pull-based model where devices regularly check in with a central server for instructions.
Okay.
A lot of network engineers find Ansible's push model more straightforward for managing that network infrastructure.
The question also mentioned that Ansible uses JSON for its scripts and that it's only for Juniper devices. Those aren't right, are they?
No, those are both incorrect.
Okay.
Ansible playbooks, which is where you define your automation tasks, are actually written in YAML, which, as we discussed, is known for its readability.
Right.
And Ansible is a multi-vendor automation tool. It's designed to manage a wide variety of network devices and other infrastructure from different manufacturers, not just Juniper.
Okay, so Ansible, agentless, push-based, uses YAML for its playbooks and works with lots of different vendors.
Exactly.
Got it right. Question 8 takes us back to XML and introduces XPath. What role does XPath play when you're working with XML data that you might get back from a network device?
So when you're dealing with structured data like XML, you often need a way to really pinpoint and extract specific pieces of information, and that's exactly where XPath comes in.
Okay.
As the question states, XPath is used to uniquely identify XML elements using expressions. Think of it like providing a specific address to locate a particular piece of data within that XML document.
So it's like a search query language specifically for XML.
Exactly. You can use XPath expressions to navigate through the different levels of the XML structure filter elements based on certain criteria and select the exact nodes or attributes that you're interested in.
Okay.
And this is crucial for parsing and processing XML data in your automation workflows.
So if you get like a big XML file back from a network device, XPath helps you zero in on exactly the information you need without having to manually sift through everything.
Exactly. It makes your automation scripts much more efficient.
So instead of manually reading through a whole bunch of XML, XPath lets you programmatically grab just the bits you need.
Precisely. And the other options in the question encryption, converting to JSON syntax validation, those aren't the primary purposes of XPath.
Okay, that's a really helpful way to think about it. Let's zoom out a bit and talk more generally about APIs. Question 9 focuses on RESTful APIs. What's a key advantage of using this type of API for network automation?
So RESTful APIs really offer a standardized and widely adopted approach to how different systems can communicate in an automated way. And the key benefit highlighted in the question is the use of standardized HTTP methods like get, post, and delete.
We hear a lot about these HTTP methods. Why are they so significant when you're trying to automate network tasks?
The real beauty of these standardized methods is that they provide a consistent way for different applications and tools to interact with the API.
Okay.
ET is used to retrieve data posts to create new resources, put T to update existing ones, and delete to remove them.
Right.
This uniformity makes it much easier to integrate different systems and build those automation workflows that involve interacting with network devices and services through their APIs.
So if a network device has a REST API, you can use these common web methods to query its status, change its configuration, and so on, all in a predictable way.
Exactly. And the question also points out that REST APIs don't require those continuous connections or store session states on the server.
Okay.
They're stateless, and while XML can be a data format used by REST APIs, they're flexible and can return data in JSON or other formats as well.
So stateless and standardized, those seem like crucial aspects for making different systems work together smoothly.
Absolutely.
Finally, question 10 brings us back to Juniper and a specific scripting language, SLAX. What's the main purpose of SLAX in Junos automation?
So this brings us back to some of Juniper's specific automation capabilities. And the question correctly states that SLAX is commonly used for event policies and system automation within Junos devices.
Okay.
It's a scripting language that has a syntax very similar to XSLT or extensible style sheet language transformations, which is often used for transforming XML documents into other formats.
Event policies. What are those used for, in the context of keeping a network running smoothly?
Event policies let you define automated responses to specific events that happen on a network device.
Okay.
For example, if a critical interface goes down, an event policy written in SLAX could automatically trigger an alert to your team, try to restart the interface, or even automatically fail over to a redundant backup link.
Wow, so it's about automating the reaction to things that are happening on the network in real time.
Exactly, making your network more self-managing and resilient.
And is SLAX the main language
Yeah.
for doing this on Junos devices?
Well, while Python is also used for automation on Juniper devices, SLAX is particularly well suited for those event-driven automation tasks and system-level scripting directly within the Junos OS.
That sounds incredibly powerful.
It is.
Given the ever-increasing complexity of modern networks, how might a deeper understanding of event-driven automation using tools like SLAX fundamentally reshape network management strategies in the years to come? Or with the growing variety of data formats used in network automation, what new challenges and opportunities might emerge for ensuring that smooth interoperability and effective data analysis across all these different systems?
Great question.
Just some food for thought as you go about your day. Until our next deep dive, keep exploring this fascinating world of technology.
Absolutely.
Right, take care.
Yep.
Bye.